Okay, this asks for a two-column proof showing the first case of this theorem. The measure of an inscribed angle is equal to half the measure of its intercepted arc. They give us a hint. Thank you very much. So let's start by writing our given, which is angle ABX is inscribed in circle X. And that is our given. Okay, I'm going to go ahead and go straight to what they suggested that we do. Draw XA. And the reason for that is that 2 points determine a line. Let's go ahead and fill that in here. So 2 points determine a line. Now, let's go for the easy stuff, right? We know that all radii are equal, so we could state that AX is congruent to BX. AX is congruent to BX. All radii are congruent. Okay, and we can mark that here and here. Now, I am going to take the easy route here, and I'm going to relabel some of my angles just to make my life a little bit easier. I'm going to call this angle 1. I'm going to call angle A up here, I'm going to call that angle 2. And I'm going to call this exterior angle here angle 3. All right? So hopefully that will make it a little easier for us when it comes time to name some things. Okay, let's go back now. Do you see that because we have these two radii here, we could state that angle 1 and angle 2 are congruent to one another because of the isosceles triangle theorem. Remember, angles opposite congruent sides are congruent. So we're going to say angle 1 is congruent to angle 2.
May I have your attention, please? We have a representative here from Sam's Club. If anybody is interested in a membership, they can come see Cynthia in the cafeteria for the next hour. Thank you.
Well, I guess you got to know about the Sam's Club representative. Just news you could use, right? Okay, let's keep going. Number 5. This is one that we haven't used in a little while, but I hope that you remember it. The exterior angle theorem. What I want you to remember about this is that this angle and this angle added together has to equal angle 3. That's the exterior angle theorem. And like I said, we haven't talked about that in a little while, but that doesn't mean that it no longer exists. So we have angle 1 plus angle 2 is congruent to angle 3. And that is the exterior angle theorem. All right, so now we also know that angle 3 here is a central angle. All right, so angle 3 and arc AC are congruent to one another. So if angle 3 is, 25 degrees, arc AC has to be 25 degrees because it's coming from the center of the circle, central angle, right? Okay, so that's the next thing we're going to state. We know that angle 3 is congruent to the measure of arc AC. And we'll call that the definition of arc measure. Okay, so that's the definition of arc measure. Now, you might be able to see where this is going already, because our goal is to prove, essentially, is to prove that angle 1 here, angle 1, is exactly half of this angle. So if we can somehow state that angle 1 and angle 1, which is actually where we're going to go right now, we're going to state that angle 1 plus angle 1 is congruent to the measure of arc AC. Now, just give me a second here. I want to show you that I've substituted twice, okay? So here I brought this down here, okay? So that's where that comes from. And then where measure of arc AC, I substituted this in. This right here was where I substituted for the behind the congruent symbol. So I basically just did substitution twice. So there is a simple definition or a simple reason, just substitution, okay? Now, we can state that, for number 8, we can state that, hang on, let me erase this here. We can state that 2 times the measure of angle 1 is congruent to the measure of arc AC, and that's just simply simplifying. And I see that I'm running out of room here, so I'm gonna put number 9 right here. Actually, I'm gonna put number 9 up here, okay? So number 9 is gonna be angle 1 is congruent to half the measure of arc AC. And the reason for that one is just simply the division property, okay? And that is exactly where we were going right here. So you're all set.